What is happening, people? Coming at you today with some special functions. So today is a huge day to use our best friend Desmos. All right, we're going to look at some unique functions today, and here they are right here. So the first thing we're going to talk about really deals with these two right here. We have this weird function we call a greatest integer function, right? It looks really weird. It actually just looks like steps, right? Like actual steps that you would walk up, like on a stairwell. Like when you walk up these steps from the first floor to the second floor, it looks like steps on a graph. Okay, and that's because we're skipping certain y values, right? Our x values, as we'll see, we're going to have most of our x values in our domain. Fancy word. We will step over, right, specific y values, right? We'll just skip them. They're not going to be in our range. Ooh. Okay. We're going to talk about piecewise functions. Piecewise functions. As the name indicates, it's a function made of pieces, right? They will give us specific domains to look at. They'll say, hey, we want to look at this function for x's between 1 and 5. And then when you get past 5, now we want this function. We're going to look at this piece of the function, right? We know that the function will go on forever, but we just want to focus on this specific domain for this function. And then these domain values will get this different function, okay? So again, it's really, guys, just 2 or 3 graphs. We take pieces of it, we put them together. They look kind of cool, right? They look kind of cool. Another one of our new functions, absolute value functions. We're going to get introduced to those today as well, right? Absolute value functions. So we should be familiar with absolute value, right? We solved those equations. We evaluated those expressions. We're going to see what an absolute value function looks like on a graph, right? I'm not sure. I'm really excited, okay? Piecewise defined functions. This kind of goes with our piecewise linear functions, right? In that we are still looking at pieces of them. I do want to give you guys a couple fun tidbits. Greatest integer, right? I'm going to write on here floor and then a set of parentheses. For absolute value function, ABS, and a set of parentheses, okay? When we use Desmos, we have to alert Desmos to the fact that, hey, we're going to graph a greatest integer function, right? If we use this word floor, it knows, oh, I got you. I know exactly what you want, okay? Absolute value function. Again, we have to somehow tell it, hey, absolute value of x plus 4. Because if we just say x plus 4, well, that's going to look different than if we want the absolute value of x plus 4. So we use, again, ABS, right? Or you can, there is the absolute value function bars. I believe they're above like the return key on that, like a couple keys above it, okay? So you can use those two, or you can just type in ABS. Either one works fine, folks, okay? All right, so let's get to all this craziness. Greatest integer function. Yeah, look, guys, here's what it looks like on a graph, right? Again, it's like steps, right? This is why we say it's a step function, right? These are all little steps as we go up. Things to remember: filled in dots, open dots. Filled in dot, include the number. Open dot, we're not going to include the number, all right? So the very first thing on here says graph, and then this is when we see, right, they're brackets with an extra line in there. Right here, I'll make it really big. So we see a bracket with an extra line, okay? Bracket, extra line, okay? This right here means greatest integer function, okay? Kind of like when we see the absolute value bars, that means absolute value function. So this means, hey, whatever is inside of this, that's what we're going to take our greatest integer function of. In this case, it's x minus 2, okay? So I'm going to show you how we graph that. Then we're going to go over domain and range, okay? Like magic, these are going to appear on here, right? Watch this. You guys ready for this? Nope. We got to go here. Are you ready to see the magic? Oh, there's no magic yet. I got to turn the graphs on. So guys, I'll show you some, look, here's all the different things we're going to graph today. It's a lot of stuff. I'll show you how you can turn on, certain graphs. Okay, so here's what we got going here, guys. And again, if you're not sure what number this is, right, if you click on this, Desmos will tell you what's going on, right? It'll give you can click and drag, you know what I mean? Like, oh, okay, here's the ordered pair for this one, okay? Here's the ordered pair for this one, okay? It'll do all that for you. So anyway, here's our graph, so you guys can go ahead and sketch that graph. And then what is my domain? So if we look carefully, like left to right, again, you know, we're at this number here, and then we kind of bounce up. But, right, my x's, they don't ever stop, right? So all of our x values are found in this domain, okay? So domain for this one, all of our x values, right? All real numbers, negative, infinity, positive. You can write in interval notation. You can write it with a compound inequality. You can even put all real numbers. I'm good with any of those, okay? Range, different story, folks. Different story. So here we go to 0, right? Then we're down here at -1, -2, -3, -4, right? This is what I alluded to earlier. I said, hey, we're going to skip some y values. So we're really just thinking like, hey, it goes, you know, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. What are all of those numbers called? So all of your positive and negative whole numbers. Think back to 7th grade math. That's right, folks. Integers, okay? So my range on this one, all integers. My domain, all real numbers. And you can just write that out, all integers, right? We don't have a fancy way to put that in there, okay? All right, let's hop back over here. So we graphed that. Well, you guys did. I showed you what to do. We gave you the domain and range, all right? Again, another greatest integer function, x plus 3. Again, state the domain and range. So let's go back over here to my good friend Desmos. Here you are. We're going to turn that one off. We're going to turn this one on. Here's x plus 3. Again, it's that same step, right, that we see. It doesn't really show up very well in there, does it? Yeah, you can kind of see it. If you got to do the old pinch zoom in there, go for it, guys. All right, domain, still all real numbers on this one, folks. If you're not sure, right, just, you know, click on these and drag and say, hey, you know what? Whoa, I don't want you to go. No, cancel. Goodness gracious. Desmos, stop. Oh, boy. Who knows what we're doing now? Cancel. I'm not going to touch anything. It's all crazy. Okay, there we go. All right, so here's our steps. That could have been tragic if it all went away. All x values are included in our domain. Again, let's look at our steps. Okay, so we're down here at -2. We step up to -1, to 0, to 1, to 2, to 3, to 4, to 5. Okay, you figured this out, right? It's the same pattern as last time. So it's all integers for a range. Okay? All right, so that was good. We'll make that one go away. An online catalog company, right? So this is an example of a greatest integer function problem, okay? So a catalog company charges shipping based on the weight of the item being shipped. Okay, that makes sense, right? The heavier something is, probably the more that you're going to pay. So they charge $4.75 for each pound or any fraction thereof, right? So if you weigh, you know, a package weighs 2 ounces versus 16 ounces, well, that's still the same weight, right? 16 ounces in a pound, guys. So if you go from a weight of 0, well, nothing's going to have a weight of 0, but right after 0, right, 0.00001 ounces, all the way up to 16 ounces, they're going to charge you $4.75. The second you go over 16 ounces, and now you're into that next pound, right, now they're going to charge you another $4.75. So whatever that is, $9.25 or something like that, okay? It's going to jump up, right? Think about what that's going to look. There's your step, right? You're going to go from $4.75, right? Then when you get past 16 ounces, right, now you're into the next pound, bam, right? Then they're going to go up another $4.75, $9.50, I think maybe, right? I think mine, look, it's crazy, guys. None of you are here today, missing you guys. Anyway, $9.50 is what this jumps up to. So think about that in terms of a range now, right? We went from $4.75 to $9.50. Then we're going to jump up another 475, okay? Draw a graph of this situation. Well, here's 3 graph choices for us, right? All right, let's just kind of analyze each one real quick. So this one says pounds. Okay, so this is our weight in pounds. So from 1 to 2 pounds, it's 475. From 2 to 3, that's where it jumps up to 950. 3 to 4, 1425. Okay. This one says for 0 pounds to 1 pound, it's 950. From 1 to 2, it's 1425. I don't really know that that makes sense. I'm kind of not sure about this one because it looks a lot like this one over here. Again, this one, I think the only difference is it looks like this whole graph is shifted left. Ooh, left and right moves, transformations. Don't worry, they're coming back. We're not done with them yet. But yeah, this is shifted left to include kind of what I was alluding to just a minute ago, right? We can have something that only weighs a half a pound. They're paying $4.75 for it. Well, in this graph over here, well, that doesn't work, right? I guess they don't ship until it gets to a pound, okay? So yeah, we want this letter here. I believe this to be a letter B, or a good old number B, as I like to say, okay? Absolute value functions. Oh, cool. Guys, here's what they look like on a graph. They make this like nice V shape, okay? Cool. Look, it even says V shape right here. Again, domain and range. We're going to have to talk about domain and range. Again, how far left and right does it go? Up and down. Usually domain is all real numbers. Our range is what changes because a lot of times they're not going to get any lower than that vertex, right? That turning point on here. Okay. We're going to come back to this one. This is a piecewise function, right? My slides are out of order. Bam. Here we go right here. So graph x plus 3. Okay. Well, guess what, guys? I've done that. Absolute value of x plus 3, here it is. Boom, looks just like this, okay? Here's that V shape. Domain and range. So once again, domain and range. How far to the left does it go? How far to the right does it go? Well, this one, all real numbers, right? All of our domain values are included. Range is a different story. How high does it go? How low does it go? Well, we know it goes all the way up here to infinity, but it doesn't get any lower than right here, right? This is at its vertex, right? This is its lowest point. What number is that? Well, that's 0 on my y-axis. So you could write this as y values greater than or equal to 0, okay? Or you could do our compound inequality. Here, we'll write a couple of these up here. So you could go 0 less than or equal to y less than infinity, right? You could go there, right? If you wanted to do interval notation, you could also just say, hey, y values greater than or equal to 0. Okay, these are all fine, whichever one you want. Okay, make that go away. Pop back here. Okay, we did that. No, we got to go backwards. Sorry. So now we get into our piecewise functions. So here's how we read this. Okay, graph, I know what that means. Here's our functions, f of x. So they said, hey, the function f of x equals negative x only on this piece right here, where x values are less than 0. So like left of 0, okay? Then when your x values are greater than or equal to 0, right, so positive numbers basically, we want to look at this function, negative x plus 2. So guys, here's how we put that into Desmos. I literally will have f of x equals negative x. And then you just need to, we call this restricting the domain. And we restrict the domain with your most favorite thing to draw in math, curly brackets, okay? So if we type that in, right, that's what it will look like, okay? So let me make this go away. And guys, you see that right here. Here, turn off this one. F of x equals negative x, and then in curly brackets, x values greater than 0, close your curly bracket. That will restrict your domain. And look, now I'm just looking at this piece of it. Here it is right here, okay? If I want to look at the other piece, look, I'm going to turn the other piece on now. Boom, there you go. It was negative x plus 2. That's its function. But now this is for x values greater than or equal to 0. right? Those start here, up here at 2, all right? Bam, bam. The only thing Desmos won't do, guys, it won't give us filled in dots or open dots. We got to think about where that is. But we can get that information, right, from each one of these domain restrictions. So if we're just less than 0, right, we know this is going to have an open dot here. If we're less or greater than or equal to 0, we know this one's going to be filled in here. So domain of this function, guys, still all real numbers, right? If we're scanning left to right, again, we got to pay attention here, okay? But it's all good because the number 0, while not included in the purple one here, I don't know if it's purple if you guys can see it, is included in my black function here, right, which was the negative x plus 2, okay? So domain, all real numbers. Range, up and down. So it covers everything. We just have to be careful, like right here. And it's okay because, look, is the number 1 included in this function? Well, it's actually in both of them. So that's great, okay? Like if this purple one ended up here at 4, now we would have to figure something out because maybe now, right, these range values between 2 and 4 might not be included in either graph. But I think we're good to go here. So domain and range are both all real numbers, negative infinity, positive infinity, however you would like to write that, okay? Bam, there was our absolute value function. Here's another piecewise function, okay? Again, I wrote this one in differently in Desmos. Just, you can type, guys, if you just type in 3x, it will graph y equals 3x or f of x equals 3x. That's what it will graph. If you just type in that, that's fine. Again, you've got to put, right, these domain restrictions in curly brackets. Otherwise, right, y equals 3x, that's just a line that goes through the origin, bam, going in both directions forever, okay? All right, anyway, it tells me this function right here models a hiker's distance in miles from the start of a trail, x hours, so there's your x variable, hours, time, after she begins hiking. Graph the function, interpret each piece of the function. So, remember, x is time. So, from 0 hours to 1 hour, she is walking or hiking at this rate. From 1 hour to 1.5 hours, we are at this rate. After 1.5 hours, we are at this rate. So we've got 3 different rates, okay? Let's take a look and see what that looks like on our graph. Okay. Alrighty. And so again, guys, right here, see how I wrote this? Again, I just wrote 3x, then I used my curly brackets to limit the domain. So this is our hiker from time 0 to 1 hour. Bam, here you go, right? So from 0 to 1 hour, there we go. All right, so hiking at a looks like a pretty good pace, okay? Here is from 1 to 1.5, right? Okay, so what was going on here, right? So this looks like, think about slope, rate of change. So we see a good rate of change here. Do we see any change here? We don't. It's 0, right? There's a slope to this line. It's 0. There is no change. What was she doing here? Probably taking a break from 1 hour to 1.5 hours, right? For that 30-minute stretch. Looks like taking a break, right? Then carries on at the end. Bam. Here it is with this green line here, right? The green line represents my last piece of the function, 2x. Okay. So again, after 1.5 hours, starts hiking again at this constant rate. Where was she hiking the fastest, I wonder? Was it the red section? We can clearly say it wasn't the blue. Or the green section, guys. Which one was she hiking faster? Well, all you have to do is look at the lines and say, hey, which one's more steeper? Which one is the steeper line? Or look at their slopes. 3, 2. So yeah, she was clearly hiking the fastest for the first hour of her hike. Makes sense, you know what I mean? Hiking not as fast, but still pretty good. There. All right, so should be good there. Getting close look. There was our graph for it, guys. Do we have to do anything else here? Sorry. Nope, just interpret each piece of the function. That was great. All right, here's our last one. Again, here's another piecewise function. okay? Here's the first piece, x minus 3, right? But we are only concerned with that functions for x values that are less than or equal to 1. So 1 and then all the numbers to the left of that. Okay, 2x, that's the other piece of the function we want, but only for x is greater than 1. So again, use these inequalities to help you with open dot, close dot. Somebody's trying to text me right now. We're going to have a filled in dot here for my x minus 3 function there at 1. We're going to have an open dot, okay, here at 1 for that one. All right, and if you need to draw those in, guys, you can. Nope, I don't need that. I just need to come back here. And let's turn on our last couple functions. So hiking goes away. Here's the first piece, x minus 3, guys. This looks like a purple line down here. Remember, this one gets a filled in dot on the end of it. And if you want to do that, go ahead and do that. Okay? The second function, let's turn that one on. Bam. Here we go up here. I immediately see a problem with this, guys. Interesting. Interesting. Do you guys see any potential issues here with domain and range? Well, domain, let's look at that. So left to right, all good, right? We're going to get to all of our negative numbers. We're going to get to all of our positive numbers, right? You know what I mean? Again, filled in here, open here. It's going to be a function. Okay, range, different story. How low does this go? Well, the purple line, of course, would go to negative infinity. But then it comes up, and it stops right here, negative 2, okay? And there is neither one of these functions have y values between negative 2 and 2. And then they pick back up again, okay? And again, we pick back up here at 2, and of course we go on forever. So we can write this a number of different ways. I think the easiest way to write this, again, domain, piece of cake. For range, guys, we can say y values that are, these are less than negative 2. So less than or equal to negative 2, because remember, we were a filled in dot, right? My purple function has the filled in dot. My black function just has the open dot, right? We got that from our domain restrictions over here. Okay, so it has a range of y values less than 2 and y values that are greater than, right, but not including, because this is an open dot, but not including 2, okay? Because really, guys, okay, so there's one way. We said, hey, here's all the numbers that it is. It's y values that are less than negative 2 and y values that are greater than 2, okay? Could you make that into a compound inequality? You could. You just have to watch your signs, right? So negative 2 would look like that, and then that would look like that, okay? So that could work, right? Because we want y values that are greater than 2, y values that are less than or equal to negative 2, okay? So that would be perfectly fine to do as well, right? Notice that our little chompy alligators are going the opposite way than what they normally are for us, right? And that's because we have this break in here, right? Where there are no y values in our function right there, okay? So guys, there you go. So that's it. So piecewise functions, absolute value functions, greatest integer functions. So 3 super crazy functions that we're dealing with here in 3-7. So again, use Desmos, guys. You got to use those keywords, right? We probably learned a lot today. Floor, absolute value, and now we know how to restrict domains, okay, as well. So enjoy. We can probably hop into all of our other stuff.